Suppose you were asked to find the enthalpy of a reaction. There are several steps to doing this. The first, as it is with many steps in chemistry, is to make sure that you start with a balanced equation. Here, we have the equation for photosynthesis. We have CO2 gas plus H2O in liquid form reacting to form C6H12O6, or a glucose molecule, plus oxygen gas. The next step in figuring out the enthalpy of a reaction is to look at all of the different parts of the reaction and to find the enthalpy of a reaction for each of those different parts. Wow, that was fast. And so now that we have all of our enthalpies of reaction for all of the individual parts of our equation, we are ready to begin calculating the overall enthalpy of reaction for this entire reaction. To do this, we are going to use Hess's law. So let's plug things in. In order to find the change in the heat of the reaction, we are going to take our products, in this case the sugar and the oxygen, and so here we have negative 1,274.5 kilojoules per mole, and we're going to multiply that by the number of moles, and here we only have 1 for our sugar, and then we are going to add our oxygen. And so here we notice that we really don't have any energy involved in this enthalpy of formation. So oxygen is just going to be 0 kilojoules per mole times 6 moles. Okay, and so that's our products. So now we're going to subtract our reactants. And first, we have our CO2, and so we see here that that is negative 393.5 kilojoules per mole, and then we are going to multiply that by the number of moles. Here we found it 6, and then we are going to add that to our last product, which is the water, the H2O. And here we see that that is going to be negative 285.8 kilojoules per mole, multiplied by the number of moles, which again is 6. And then we close off that bracket. So all we have to do from here is simplify. And so we have our heat of reaction. It's going to be equal to our products. And so let's simplify that. Here we have the energy associated with our sugar molecule times the number of moles, which is just 1, so it stays the same. And then we're adding 0 times 6 for our oxygen. And so that's going to be plus 0, which is just going to make it the same. So we have 1,274.5 kilojoules per mole for our products. And then we're going to subtract our reactants. And so here we have 393.5 kilojoules per mole times 6, which is going to give us negative 2,361 kilojoules per mole. And then we are going to add our last bit, our H2O here. And so that is going to be 285.8 kilojoules per mole times 6, which is going to give us a negative 1,714.8 kilojoules per mole, close parentheses. And so now we have to simplify even more. So we have our heat of reaction is equal to our products, here 1,274.5 kilojoules per mole. And then it's going to be minus what is ever here in our reactants. And so here we have negative 2,361 kilojoules per mole plus a negative number, and so that means that it's just going to be minus. And so if we have a negative number minus plus another negative number, that means that this number is basically just going to be getting larger, so a larger negative. And so this is going to be minus 1,714.8 kilojoules per mole, and this is all going to equal out to be negative 4,075.8 kilojoules per mole. And last step here, and so here our final answer is we are going to have 5,350.3 kilojoules per mole. And now here we are almost done, but we do have one more very important step. We are going to check our answers. And so here we know that because this is a positive value, that it takes energy to make this reaction happen. You have to put energy into it. And so this, we know, is going to be an endothermic reaction. So I'm going to go ahead and I'm just going to double check my work here. And the number one mistake that people tend to make with these kinds of reactions is they just drop a negative sign. And so you need to pay very close attention to all of the signs that you're using here for your energy. And so let's check our original equation here. So we have the heat of reaction is going to be 1,274.5 kilojoules per mole. And so we go up here to check that for our sugar molecule. Oh, what's this? I realize here we have a negative number, but here I copied it down as a positive number. And so that, like I said, number one mistake people make, this can really end up messing up our answer in the long run. And so let's go ahead and check our work again. So let's make this a negative number. And so we know that in this step here, nothing really happened to this number. So that is just going to be a negative. We don't have to change the math. And here, we know that the product side did not change again. So it's just going to be like that. And so really the only part that we really have to redo here is this very last step. And so let's go ahead and redo our calculations here. Since we know that this answer is not correct, let's say the heat of reaction is going to be equal to 1,801.3 kilojoules per mole. And there you have it.